Question 9. So we're sending a message digitally of n bits, and there's some independent error rate. So the error probability is p independently for some bit. Let the random variable denote the total number of errors in the received message. We're asked what the probability of distribution of x is. These are independent trials. They're repeated independent trials where each trial can either be an error or not be an error. So it's a binomial distribution. All right, so the answer to A is binomial. So think about how this distribution comes about. We've got some probability of error P, and there's X of them. Then there's the probability of an error-free bit is 1 minus P, right? And in a message of n bits, n minus X of those are error-free. And there are several ways to organize this. There are n choose X ways to organize this string of bits. If we want to go further, we can write out this n choose X. That's n factorial over x factorial n minus x factorial. Right, so this is something we can actually stick into our calculator and evaluate. If we know n and p, and then we just cycle through, x goes from 0 to n. So for the third part of this question, we actually have to do that. We have to substitute in n equals 4, p equals 0.2, and then write down a table of values, which I've done here. Right, so, oops. It's just a formula bash, so there's no point in me really illustrating that carefully. What we're going to think about is the probability that we've got at least 2 errors. So we've got to frame that carefully. Probability x at least 2, greater than or equal to 2, like so. We can now think about this in terms of finitivity and complements. So at least 2 errors means that we get, there's only 4 of these, so I'm going to do it pretty manually. We can either get 2, 3, or 4 errors, and the probability, and we're just summing these. This is a question more about the cumulative distribution. So that's 0.1536 plus 0.0256 plus 0.0016. Right, so that'll have some number that you can put into your calculator. The expected value, the expectation of x is given by this formula. So it's a weighted sum. It's x times the probability of x. So for example, this works out to be 0 times 0.4096 plus 1 times 0.4096 plus 2 times 0.1536 plus 3 times 0.0256 plus 4 times 0.0016. Okay, that's something we can stick in our calculators and work out. The variance is x minus the expectation squared times the probability. So I need to actually stick this into a calculator to work out my expectation, so I'll do that now. 1 1 4096 plus 2 times 0.1536 plus 3 times 0.0256 plus 4 times 0.0016. Okay, 0.8. There is a formula you can remember for the expectation of a binomial. You can actually calculate it explicitly, but that's fine. So this is now 0 minus 0.8 times 0.4096 plus 1 squared minus 0.8 squared times 0.4096 plus plus 4 minus 0.8 squared times 0.0016. That has some answer, which I'm not going to compute. I'm too lazy to put that in my calculator, I'm afraid. The standard deviation is just the square root of the variance. So once you have this variance value, you can compute the standard deviation.